Find the area between two curves expressed as functions of y rather than functions of x. Like, for example, anytime you had, let's say I just have a regular line, y equals mx plus b, I could decide to rewrite this by getting the x by itself. Can you see that if you got the x by itself, you'd have to move the b over and divide by m? Can you imagine how confused you would be if I said, we're no longer doing y equals mx plus b. From now on, we're just going to start talking about x equals y minus b over m. You'd be like, what? It's so weird. Because you're not used to it, right? But basically, it's the same idea. We're just rewriting things so that the x is by itself rather than the y by itself. And so that makes x a function of y. You could have that in two different functions, and maybe this would be easier. And now you can still find the area, but now you're partitioning the y-axis. So you think about a horizontal line up and down rather than the horizontal line left and right. Okay? So let's see what this looks like with some examples.
Just need to write down.
Oh, sorry, I forgot that I had left the blanks in there. Got excited. Just let me know when you're done. And then because we're doing it in terms of y, we have dy instead of dx. Okay. So normally, if I wanted to find the area between those two curves, it seems like I'd like to find my intersection points and want to know my x coordinates, and then I would do the blue one minus the red. But unfortunately, the way the questions are written is they're already written as x in terms of y. The x is by itself, not the y by itself. So instead of finding the area from 0 to 4, I'm now thinking about finding the area from -1 up to 1 along my y-axis. It's kind of like you're taking your graph and you could flip it and then put it the other way. So when we find our intersections, now I'm only really care about the y coordinates, because I want to go from -1 up to 1. And I'm going to do the curve on the right minus the curve on the left. So the line is to the right, and the parabola is to the left. And after that, everything is identical to what you've done so far. Again, I'm going to save you time, just show you the answer.
Here's Isaacs test. I looked through it, looked pretty weak. I didn't look through it.
I got that on the This one's going to go viral. Everybody good? Almost? This example actually would be really hard if you tried to do the area between the two curves. Because there's an area between the two curves horizontally up to here, and then it's just a weird thing after that, where it's not between the two curves anymore. But along the y, it still matches up very nicely from -2 up to 1. Again, how do we find out it's -2 and 1? We would set up the equation and find the intersection points. So you would just have 3 minus y squared equals y plus 1, and that would factor nicely. And then the one on the right is the parabola. And the one on the left is the line. And the integral is easy. And again, I'll save you some time with writing numbers down. You don't need to. You could plug in the numbers correctly, I know. And I know that if I show you, you will write that down. So this saves you time. Next one's fun. They're all fun, in my opinion. But, oh my goodness. They give you one equation that's y equals, and one equation that's x equals. And you need to find that area. So you sort of have a choice. Do you want to break up it along the x-axis and figure it out? Or do you want to break it up along the y-axis? Y equals the square root, that's our red graph here. Maybe I'll color code this. This is our red graph. And x equals 9 minus y squared. That's our blue graph on there. And we have to decide what we think would be easier to do. Would it be easier to partition the x-axis or to partition the y-axis? So partitioning the x-axis. First of all, we would have to get both equations to be y equals. So in this situation, can you see that I could get y squared equals 9 minus x by moving the y squared to the left and the x to the right? And then how do I get rid of a squared? I would square root it. And that square root has a plus or a minus. The plus is the square root that's above. And the minus would be that half of the parabola where the square root is below. Did you know a sideways parabola is just two square root graphs put together? So then in partitioning the x-axis, these are our two functions. The one which we were given, 9 minus 9x, and the other one, 9 minus x. And as far as what's happening here, well, I actually have two different areas if I crayon it. This area in orange would just be the area under the curve of the blue graph to 0. And this little section between 0 and 1 would be the area of the top curve minus the bottom curve. So I have to think about that and say, oh, I have to do 0 to 1 differently than I do the 1 to 9. 1 to 9 will just be the integral of the 9 minus x, and the 0 to 1 I would have to subtract. And I could play around with this a little bit if I wanted to, or I could do it separately. Do you see the 0 to 1? I could do each the 0 to 1 of this one minus the 0 to 1 of the other one using my properties of integrals. And then the 0 to 1 and the 1 to 9, I could actually put those together as 0 to 9. And some of you might actually think of it this way. Okay? It wouldn't be wrong if you wrote this out to begin with. Can you visualize that if you took the area of 0 to 9 underneath the blue one, that would cover everything, and then you just have to subtract from 0 to 1 of the other one? If you thought of that directly that way as well, that'd be perfectly fine. Simple power rule, but you'd have to divide also by the negative because of the chain rule. So this is the 1/2. I'd add to the exponent to make it 3/2. So I'd also have to divide by 3/2, which would give me 2/3 when I flip that. But because the inside has a negative and there would be a chain rule, we also need a negative out front. Same thing on the second one. Add 1 to the exponent. Also divide by 2/3. But then you'd also have a divide by -9 because of the chain rule, which will make you have a -2/27 out in front. Probably, if I were you showing my work, I'll do this one right here, and I'll do this one in purple. I would probably have done this first. I would have done that first because I like to see the half. Then I would have added 1 to the exponent and divided by that. And also said I'm going to have a chain rule normally where I multiply by -9. So I need to divide by -9, which I made -9/1 to get that as a fraction. Can you see the bottom fraction now would be -27/2? And dividing by a fraction, multiplying by the reciprocal, shows why you have a -2/27 out in front. But it's one of those things, if someone just goes from here to here, you're like, haha. Number fright, like where'd that number come from? I would show that work, especially on an exam. Not worth doing all that mental math in your head only to make a mistake. And then when we plug all those things in, you just get 16. It's crazy. So that's partitioning the x. We could have also done this one by partitioning the y. So now, what we need to do is we need to get both equations x equals. So this equation that was y equals, you'd have to square both sides, and then move things over to get the x by itself. So you get x equals negative y squared over 9 plus 1. And partitioning the y, in my opinion, is actually easier here, because you don't have to worry about different parts. Can you see that you could just go from 0 to 3 of the blue minus the red? And there's a lot, like there's no square roots, right? I had to do all of those product rules with chain rules built in. With the y, it's a much easier integral of adding 1 to the exponent and dividing. And we still get 16.